afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna light it up. Tonight, we gonna light it up. Tonight, we gonna light it up. Just like the sunrise, we gonna light it up. Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna light it up. Tonight, we gonna light it up. Tonight, we gonna light it up. Just like the sunrise, we gonna light it up.
That can be formed using digits 1, 2, 3, 4, and 5. So again, see question number 4. See the total number of dates available. How many dates are available? 1, 2, 3, 4, 5. So we have 1, 2, 3. These 1, 2, 3, 4, 5 digits are available. And we have to form 4-digit numbers. We have to form 4-digit numbers. So without repetition, by method of counting, 4 digits. 1, 2, 3, 4. First place can be filled in how many ways? First place can be filled in 5 ways, or 5 digits are available. Second place in 4, 3, 2. That's it. Do it. Multiply. What will be? So you should multiply. Therefore, multiply. Again, its second bit. Its second bit is how many of these will be even? So its second bit, how many of these will be even? See that for even number, check it whether do we have a restriction for any of the places. Yes, we have. For even number, there is restriction for the last place, is it? Last place, we cannot use all those 5 digits. The number to be even, from those 5 digits, we can use only these 2. Only 2 and 4 can be used. So last place can be filled only using 2 digits. They are 2 and 4. Only either 2 or 4. These 2 numbers are possible. So last place, last being an even number, last place can be filled in 2 ways only. In bracket we can write using 2 and 4. Last place can be filled in 2 ways. Last place can be filled in 2 ways. Now, so out of this 1, 2, 3, 4, 5 digits, we already use 1 digit. Remaining how many digits can be used here? 4 digits can be used, 3 can be used, 2 can be used. So then first place can be used. First place can be filled in 4 ways. Second place in ways, second place in 3 ways, 2 ways. So total number of numbers is 4, 3, 48. We did it earlier, the number of numbers. So all such questions, formation of numbers using digits. If few digits are given, formation of numbers, I think counting, method of counting will be easy. Method of counting will be easy. See, in method of counting or in otherwise, see that always the preference is for those places with restrictions. If you have any place with a restriction, you have to fill that place first. Here, even number. Even number means there is a restriction for the last digit. The last digit to be an even number, it should end with even numbers. So here, these are the available digits. In these available digits, we cannot fill the last place by using any of this 5, because to be an even number, the last place should be either 2 or 4. That means we have only 2 options. That is not the option. This 2 is not this 2. This 2 stands for the number of possible ways to fill it. The number of ways the last place can be filled. We have 2 ways. 2 ways means it can be 2 or 4. So last place is filled. Remaining 3 places, no restriction. So we can start from first round. Out of this 5 digits, we already used 1 digit for the last place. So remaining 4 numbers can be used here. Only 3 numbers left out. Only 2 numbers left out. So this is dot number. Now, coming to next question number 5. From a committee of 8 persons. From a committee of 8 persons, how many ways can we choose a chairman and vice? So from 8, how many are to be selected? From 8 persons, we have to select 2 persons. Out of n, we have to arrange 2 persons. Out of n, r things can be arranged in npr ways. So out of 8, 2 can be arranged in how many ways? 8 be 2 ways. So write it out of 8. Out of 8, number 5. Out of 8, 2 can be arranged. Means 2 means chairman and vice chairman. The 2 places are chairman and, see, previously it was 3-digit number. So those 3 places, 100th place, 10th place, 1st place. Instead of that, here the 2 places are, 1 place is for chairman, the other place is for vice chairman. So 2 places. So the idea is, see, so out of 8, 2 places can be arranged in how many ways? 8 be 2 ways. That is 8 be 2, 8 factorial by, it is 8 factorial by 6 factorial, 8 into 7 into 6. 56 possible ways are. Possible ways. Now, yes, Shashank, no problem. This is by method of counting. 2 places we have to fill it. First place can be filled by any of those 8. Second place, remaining 7, any of those 7. So 8 to 7, again same. Next one can be asked for 2 marks. Question number 6. See this one. I will show you how to do it. Then do by yourself. Find n if n minus 1 p3 n minus 1 p3 is to np4 is equal to 1:9. N minus 1 p3 is to np4 is 1:9. See, by definition, n minus 1 p3 means n minus 1 factorial by n minus 1 minus 3 factorial is to, is it? NPR means n factorial by n minus r factorial. N minus 1 p3 is n minus 1 factorial by n minus 1 minus 3 factorial. NP4 means n factorial by n minus 4 factorial is equal to 1:9. This is n minus 1 factorial by n minus 4 factorial is to n factorial by 1:9. Is to means division, is it? So division means n minus 1 factorial by n minus 4 factorial whole by n factorial by is equal to 1/9. Now division by a fraction means multiplication by reciprocal. What is reciprocal? N minus 1 factorial by n minus 4 factorial multiplied with reciprocal of this one. N minus 4 factorial by n factorial is equal to 1/9. This can be cancelled. Again, n minus 1 factorial, n factorial. We know that, we discussed in the previous class, we will break the bigger one. Out of n minus 1 and n, which one is bigger? N is bigger. So we break, keeping the smaller one as it is, we break this bigger one. N factorial starting from n, then subtract 1. N minus 1 factorial, then you can stop because n is equal to 1/9. This cancels. 1/n is equal to 1/9. N is equal to 9. Can be asked for 2 marks. Hope you have completed. Say next one, exactly same. Find R if question number 7, first bit, 5PR is equal to 2 into 2 times 6PR minus 1. 2 into 6PR minus 1. See here, I'll show you. 5p by definition, it is 5 factorial by 5 minus r factorial 2 into 6 factorial by 6 minus r plus 1 factorial. How it is plus 1? 6 minus of 6 minus of r minus 1. Just shows inside. 6 minus of r minus 1 is 6 minus r plus 1. That is 5 factorial by is equal to 2 into 6 factorial. This is 7 minus r factorial. Now see that left side, right side. For cancellation, we will break the bigger one. 5 factorial and 6 factorial. Out of these two, we know that 6 factorial is bigger. So we can break 6 factorial. Similarly, out of 5 minus r and 7 minus r, which one is bigger? 7 minus r is bigger. So these two we will break. How to break? So left hand side 5 factorial by 2. 6 factorial we can break it as 6 into 5 factorial. 7 minus r factorial. Starting from 7 minus r, 1 subtract 1. 7 minus r minus 1 is 6 minus r. Again subtract 1. 5 minus r factorial. Now you can observe it. This 5 factorial cancels from numerator. 5 minus r factorial, this cancels. Left hand side, we have 1. Right hand side, 6 2s are 12 by 7 minus r, 6 minus r. Cross multiply. Cross multiplying, what do we get? 7 minus r, 6 minus r is equal to 12. Open the bracket. 7 6 are 42 minus 7 r is it? Arranging r squared minus 13r plus 42 minus 12 is 0. R squared minus 13r. This is a quadratic equation. Solve it. Solving, what do we get? Solve it. 15. This is r minus 15. Okay, I think 5p r 2 into 6. Did we go wrong somewhere? 6p r minus 1. Check the question is correct. 5 2 into 6p r minus 1. I. See, this is correct. 7. Product is positive. Sum is negative. If product is positive and sum is negative, that means which are the factors? Both the numbers are. Otherwise, solve using quadratic formula. Using discriminant find. Product is 3, 10 into 3. Minus 3 into minus 2, minus plus 30. Minus 3 minus 10 is minus 30. So R minus 3. R is equal to 3. See, in all quadratic equations, last year also you learned it, we may get one solution, or sometimes you may get more than one solution. Whenever we get more than one solution, check whether we can accept both the values. Sometimes both values can be accepted. Sometimes both cannot be accepted, and sometimes one only will be accepted. So here, value of R can be 3 or can be 10. See that definition NPR. The meaning of NPR is out of n things, R things can be taken. So out of n things, R things are taken means this value of R can never be more than n. Why? Out of 10 people, can we arrange 15? No. Out of 10, maximum you can arrange 10. Out of 10, you cannot arrange 11. Out of 10, you cannot arrange more than 10. Maximum all those 10. That means out of, whenever we get NPR, that R will be always less than or equal to N. R can never be more than N. That means here, this 10 is not possible. Reason 5p10 is not valid. It's not possible. Whereas 5p3 is possible. So in this case, remember it, NPR. Whenever we get NPR, R cannot be fraction. R cannot be negative. Even R cannot be a number more than N. So here, R will 10, right? Rejected since 10 greater than 5. Or rejected since R less than or equal. This is it. Therefore, R is equal to 3. So, second bit is a homework. Second bit, survey yourself. Now we come to the next type of questions. Again, they are interesting ones. That 8 one. See, till now, I hope you have completed. So till now, we did questions based on numbers from a given digits. How many 3-digit numbers? Now, words. See, question number 8. We have a word given. Equation. This equation. The question is, how many words? Again, see that we learned it, the numbers in our number system. Actually, numbers is reshuffling or permutations of the digits from 0 to 9. In all, we have 10 digits available, is it? From those 10 digits, reshuffle those numbers, those digits, we get numbers. Similarly, all our English words, They are reshuffling of those letters from A to Z, is it? Letters A, B, C, D, etc. up to Z. If you are reshuffling it and arranging it, we get some words. Definitely, those words, it is with meaning, or here, without meaning means just any arrangement. So here, how many words with or without meaning can be formed using the letters of the word equation? Using each letter exactly once means without repetition. See here, whenever you get such words, first thing is count the total number of letters and also check whether any letter is repeating. Here we use the last formula. Out of n objects, if p are of the same kind, then n factorial by p factorial. So in this one, what is the total number of letters? Total number of letters is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters. Of these 8 letters, check it whether we have any repeating letter. E is not repeated, Q is not repeated, nothing is repeated. So no letter repeated. No letter is repeated. Now the question is, how many words can be formed using all the letters? So out of n things, if all can be arranged in how many ways? Without repetition, out of n things, n factorial ways. So all these 8 letters can be arranged in 8 factorial ways. See that all letters, we have 8 letters available. In this available 8 letters, we are using all the letters. Out of n things, all can be arranged in n factorial ways. So 8 letters, if you are taking all letters together, it can be arranged in 8 factorial ways. Whereas out of 8 letters, if we are taking only 5 letters, if you are only arranging 5 letters, it is 8p5 ways. 8p5 ways. Out of 8 letters, if all are taken, it is 8p8, that is 8 factorial ways. See, we have only 2 formulas, NPR, NPR, and n raised to r. NPR is without repetition, n raised to r is with repetition. NPR, out of n, if r things are taken, NPR. Out of n, if everything is taken, NPN. NPN becomes n factorial. N factorial. So here, out of 8, if all are taken means 8p8, which is 8 factorial. Therefore, total number of words is equal to 8, 7, multiplied 8 factorial, multiplied. What do you get? Multiply this number as 8 factorial, we get the answer. Yes, 40. It is with or without meaning means we have, if you are starting with Q, Q is, it is a word without meaning, but it's a word. It is without meaning. So all words are formed by reshuffling the letters of this alphabet, this English alphabet. Now, question number 9. Again, how many words with or without meaning can be made from the letters of the word Monday? Again, write total number of letters. Question number 9. The given Monday. Total 1, 2, 3, 4, 5, 6. Previously, instead of letters, those digits were given 1, 2, 3, 4, 5, or 8, 2, 8, 7, or 5, 6, 7, 8. Letters were given. Instead of letters, instead of digits, here is letters 1, 2, 3, 4, 5, 6 letters only. Do we have any repeated digits? Repeating digits? No letter, no letter repeated. Now we have to arrange 4 letters. So first bit, out of 6, 4 letters can be arranged in how many ways? Out of 6, 4 letters can be arranged in 64 ways. Right? Out of 6, 4 letters can be arranged in 64 ways. Again, only 2 formulas we are using. NPR. NPR stands for out of N, R things can be arranged. Same thing. Here, out of 6 letters, 4 things can be arranged in 64 ways. Therefore, total number of words is 64. 6 factorial by 6 factorial by 2 factorial, 6, 5, 4, 3, 6 into 5 into 4 into 3, multiplied 30. This 360. It's second bit. So out of 6, 4 letters can be arranged in 64 ways. Second bit. How many are arranged? Out of 6, all can be arranged. In how many ways? Out of 6, all can be arranged in 66 ways. Or it is 6 factorial. In 66 ways. Or 6 factorial. 6 is 6 factorial. Why? 6 factorial by 6 minus 6, 0 factorial. So remember it. Out of n things, r things can be arranged in npr ways. Out of n things, all can be arranged in n factorial ways. Actually, it is npn only. It is n factorial ways. Therefore, total number of words is 6 factorial. 6, 5, 4, 3, 2, 1. Multiplied. Project 728. Now the last bit. Third bit. See, third bit. Again, out of the 6 letters, all letters are used. But there's a restriction. Restriction for which place? First place. In first place, it has to start with a vowel. So in first place, can we use all the 6 letters? No. At the first place, we can use only a vowel. So in this given letter, how many vowels are there counted? Which are the vowels? How many vowels are there? 5p6. 5p. Someone wrote 5p6. 5p6 is meaningless. 5p6 is meaningless. Out of 5, 6 is here. How many vowels are there? 2 vowels. So the first place from 2 vowels. From 2 vowels, how many? Only 1. First place means we have to fill the first place. First place means we have to fill only 1 place. From 2 vowels, 1 can be taken in 2p1 ways. 2p1 ways means 2. But first place can be filled. First place can be filled in 2p1 ways. Listen. From 2 vowels, 1 is taken. From 2 vowels, 1 is taken. That is only for the first place. Now, so we have to use all letters. All letters means we have to fill 6 places. Out of 6 places, first place we fill. First place in 2 ways because only 2 vowels. Remaining how many places? 5 places. In that 5 places, it can be filled in 5 factorial ways. So remaining 5 places. Remaining 5 places can be filled in 5 factorial ways. Therefore, total number of words is 2p1, which is 2 into. See, in all we have 6 letters. That means if we are arranging all letters, that means we have to fill 6 places. 6 places are to be filled. Out of the 6 places, the first place we have to start with a vowel. So to fill the first place, we have only 2 options. From that 2 vowels, 1 can be filled in 2p1 ways. 2p1 ways means same as 2 ways. So first place can be filled only in 2 ways. Remaining 5 places, we have 5 letters available that can be filled in 5 factorial ways. Remaining 5 places using 5 letters, 5 places can be arranged in 5 factorial ways. So total number of words is 2 into 2p1 into 5 factorial, or 2 into 5 factorial, which is 5 4 240. So 240 words are possible. So we'll continue tomorrow. Oh, I took 3 minutes extra, no problem. Tomorrow I will leave you 3 minutes earlier. Anything else? No. Okay. So see you tomorrow. I'll give 3. So we were doing permutations and combinations. And permutations means the arrangement. Permutation is the arrangement. And we discussed the method of counting. Also the meaning of factorial. See that n factorial. The meaning of n factorial, just a recap. N factorial means 1 into 2 into 3 into etc. up to n. So 5 factorial means 1, 2, 3, 4, 5. Multiplication up to 5. 1 into 2 into 3 into 4 into 5. 3 factorial means 1 into 2 into 3. That is notation factorial. So n factorial means 1 into 2 into 3 into etc. up to n. Or we can start with n. Starting with n, subtracting 1 by 1. For example, 4 factorial. 4 factorial, either you can write 1 into 2 into 3 into 4, or 4 factorial, we can start with 4. Starting with 4, then 1 short. So keep on subtracting 1. So 4 into 3 into 2 into 1 till 1. That is factorial notation. Again, simplification of this factorial also we discussed it. Simplification of factorial. For example, if we get n factorial and n plus 2 factorial. Here, what we do is we break the bigger one. Breaking the bigger one. Out of n and n plus 2, which one is bigger? N plus 2 is bigger. How to break it? Starting from that number, then keep on writing numbers by subtracting 1 by 1. That means out of this n plus 2 factorial, n plus 2 is the bigger one. So we keep the n factorial as it is. N plus 2 the factorial, n plus 2 factorial, bigger one. How to break it? Starting from n plus 2 into the next number. The next number is 1 less than this. N plus 2. If we subtract 1, it will be n plus 1. Again, if we subtract 1, it is n. Chapter factorial. So this n factorial is cancelled, remaining is n plus 2 by n plus 1. Similarly, if it was some n minus 1 by n minus 3. Out of n minus 1 and n minus 3, which one is bigger? N minus 1 is bigger. So we break the bigger one. N minus 1 we can break. How to break it? Starting from n minus 1. Then 1 less than that. Subtracting 1. N minus 1 minus 1 will be n minus 2. Again subtracting 1. N minus 3 factorial by n minus 3 plus cancels. So this 10 factorial and 8 factorial can be simplified. How to simplify? Starting from the bigger one. Bigger one, break it. Out of 10 and 8, 10 is bigger. So breaking 10, we start from 10 into subtract 1. 1 less than 10 is 9 into again 1 less 8 factorial by 8 factorial. Whenever we stop, we can stop with the factorial. This is how to simplify. This is how to simplify factorial. So this is the meaning of factorial. Then we discuss permutations. The formula, 3, 4 formulas. Remember, permutations, first thing. Out of n things, R things can be arranged without repetition in NPR days. NPR days. Out of n things, R things can be arranged in NPR days. And by definition, NPR is n factorial by n minus r factorial. So NPR stands for the number of permutations of n things taken R at a time. number of permutations means number of arrangements. For example, if we have 5 digits available, the available digits are 5, 6, 7, 8, 9. We have these 5 digits. You were asked to form 3-digit numbers. That too without repetition. Without repetition. So using these 5 different digits, how many 3-digit numbers can be formed without repetition? See, for example, the 3-digit numbers. If I'm writing those 3-digit numbers, 567, using these digits, I wrote a 3-digit number without repetition, 567. Whereas I cannot write 556. This is not possible. Why is it not possible? You were asked to write those 3-digit numbers without repeating digits. Here, the digit 5 is repeated 2 times. So it's not possible. So without repetition, so 567. See, in this 3-digit number 567, no digit is repeated. Similarly, another number starting with 5, 568, 569. Is it? Then we can write 576. Again 570. 5 is not possible. 5 is repeated. 576. 578. 579. Again 589. 586. 587. 589. Similarly, starting with 5, we can write a lot of 3-digit numbers using this digits. Now, to count the total number of, so how many such numbers are possible? So using this formula, if you're writing this and counting, it takes a lot of time. So using this formula, NPR means out of n things, r things are taken together. So here, out of this 5 digits, we have to arrange 3 digits. Out of 5, 3 can be arranged in 5p3 ways. Out of n things, r things can be arranged in NPR ways without repetition. Out of 5 things, out of 5 digits, 3 digits can so 3 digits can be arranged in 5p3 ways. 5p3 ways means 5 factorial by 5 minus 3, 2 factorial. Again, we discuss it, breaking. This is 5, 4, 3 into 2 factorial. Why? Because bigger number we can break one by one. So the answer is 5 into 4 into 3, which is 2060. That means using these 5 digits, 5, 6, 7, 8, 9. In all, we can form 60 different 3-digit numbers. We can form 60 3-digit numbers without digits are repeated. This is ENP, the first formula, ENPR. Shall we copy this? Shall we write this? No, these are just revising. If you want, we can write, but this we discussed it. Before vacation, we discussed these things. We discussed this before vacation. Yes, anyway. So this is NPR. So NPR stands for the formula out of, again, this people keep on saying, if you keep on coming, it's a disturbance. Out of n things, r things can be arranged in NPR ways. This is without repetition. If it is, again, this one, by the method of counting, we did it. By method of counting, we did the previous exercise. Counting means we need to fill 3 places, no restriction. To fill 3 places, first place, see, in such cases, first we fill the place with restrictions. In this case, we don't have any restrictions at all. So taking the first place. In this first place, these 5 digits are available. So this first place can be filled in 5 different ways. Any of those 5 dates can be used. Since it is without repetition, the second place can be arranged in 4 numbers and third one in 3 ways. Out of 5, 4, 3. Again, same thing, 5, 4, 3. This is by the method of counting. And all this numbers, formation of numbers, I think method of counting will be a bit more easy. Whichever is comfortable for you, go for it. No problem. So this is the first one, NPR. So NPR stands for the number of permutations or number of arrangements. Out of n things, if you are taking r things at a time, that too without repetition, that is NPR. Now, if it is with repetition, it will be n raised to r. If it is with repetition, n raised to r. With repetition means, in this case, out of 5 digits, how many 3-digit numbers can be formed with repetition? Repetition of digits is allowed. In the previous case, we didn't take the number 565. We didn't count this number 565. The reason the digit 5 is repeated. But in this case, repetition is allowed. Even 565 we can count. Even 555 we can count. The digit 5 is repeated. Repetition is possible. If so, using these 5 digits, in all, how many 3-digit numbers can be formed? N raised to r. So 5 raised to 3, 5 cubed. In all, 125 different numbers can be formed. If it is without repetition, see that it was only 60 numbers, whereas with repetition, 125 numbers, because 5 cubed. Or again, by the method of counting, we did it. First place can be filled in 5 ways. Second place, again, these 5 digits can be again used because repetition is possible. Third place also 5. So for each place, 5 different possibilities. 5 into 5 into 5, that is 5 cubed for the same. So without repetition, NPR. With repetition, n raised to r. This is out of 5 things, out of n things, if r things are taken. Whereas out of n things, if all are taken, for example, using those 5 digits, how many 5-digit numbers can be formed? Or by making use of all these digits, how many different numbers are possible? Without repetition. Without repetition, so exactly again, out of 5 things, all things are taken means it is NPN. Out of n things, if r things are taken, NPR. Out of n things, if all are taken, it is NPN. NPN means, so if all are taken, NPN means n factorial by n minus n. N minus n is 0 factorial. And by definition, 0 factorial means it is 1. So it is n factorial. So out of n things, if all numbers are arranged, if all objects are arranged without repetition, it is n factorial ways or npn ways. Same thing, n factorial. With repetition, n instead of r, it is n. So n raised to n ways. Again, by method of counting also, we can observe it, we get the same answer. We discussed it in previous classes. Again, one more thing, out of n things, if p things are of the same type or same kind, then the number of permutations will be n factorial by p factorial. This we discussed later on. While doing questions, we will get the idea. So these are the formulas: NPR, n raised to r. These are 2 basic formulas. With that, if r things are taken, NPR. If all objects are taken, NPN. NPN means it is n factorial only. So this is the basic things. Again, we discussed factorial, the meaning of factorial. Again, NPR, the meaning of NPR. NPR is out of n things, r things are taken. So 7.3, we did the first one, 2-3 questions, I think. Still, we will do it again. By method of counting, you have to try. I'll show you how to do it by using this permutation formula. First one, how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated. So in all, 1 to 9. 1 to 9, how many digits are there? From 1 to 9, in all we have 9 digits. In that 9 digits, we need to form 3. Not only first one, I know that this executed it, but still we are discussing it once again. Out of 9 digits, there is no restriction for any places. So out of 9 digits, we need to arrange how many digits? 3 digits, because 3-digit number. So out of 9 digits, 3 digits can be arranged. Out of n things, r things can be arranged in NPR. Out of 9 digits, 3 digits can be arranged in 9p3 ways. So right, out of 9 digits, 3 digits can be arranged in 9p3 ways. That is 9p3, 9 factorial 5, which is 9 factorial by 6 factorial. Again, 9 factorial and 6 factorial. We will break the bigger one. Bigger one is 9, 9, 8, 7, 6 factorial by 9 into 8. Multiply 9 into 8 into 7. That gives the answer. In the meantime, I will take the attendance. This. Again, the same question by the method of counting. By method of counting, we need to fill the place. And I think these questions, this number question, method of counting will be much easier. No restriction at all. So first place can be filled. In all we have 1 to 9. 1 to 9, we have 9 digits. So first place can be filled in 9 ways. Again, second place, it is without repetition. So second place, we can use only 8 because 1 is already used. And third one, 7. And again, same 9 to 8 7. That's it. Now coming to question number 2. Question number 2. See question number 2. How many 4-digit numbers are there with no digits repeated? How many 4-digit numbers with no digits repeated? So here, in all, how many digits are available? How many digits do you know in all? See that all of us know only 10 digits. Which are those 10 digits? Starting from 0. 0, 1, 2, 3, 4, up to 9. In all, we have 10 digits. All our numbers, whatever numbers we learned till now, all in number system, all our numbers, they are the permutations of these 10 digits, is it? The digits are 0 to 9. 0 to 9. After writing 9, the next number 10, actually 10 is the permutation of the first 2 digits, which are 0 and 1. 0 and 1, we put 1, then 0, that means it's 10. So all those numbers, they are permutations of digits from 0 to 9. Means we are reshuffling these digits, that's all. arranging, we get a number. Our system, that's why our system, that is called denary system. Denary system with 10 available digits. Whereas in computers, the binary system is used. In computer, only 2 digits are 0 and 1. Those who have taken computer science, you may be knowing it, 0 and 1. That is called the binary system. Binary system has only 2 digits, 0 and 1. Denary system. For denary system is having from 0 to 9, 10 digits are available. So here, so in all we have 10 digits available, 0 to 9. We need to make a 4-digit number. Do we have any restriction? By method of counting we know it, but still. Question number 2. First of all, think it. Do we have any restriction for any of the digits? The question, had it been an even number, if the question was to find an even number, then definitely there is a restriction for the last place. For even number, last place should be either 0, 2, 4, 6, 8. Only these 5 digits are possible. Only numbers ending with 0, 2, 4, 6, 8, they are even numbers. If it was an odd number, again, restriction for the last place. Similarly, it's a 4-digit number. Do we have a restriction for any of the places? What do you feel? At one glance, you may feel that there is no restriction for any. It is without repetition. No days are repeated. You may think there is no restriction for any of the places. We have a restriction. Restriction for which place? Restriction for the first place. Why there is restriction for the first place? We need a 4-digit number. As we need a 4-digit number, if we write 0 in the first place, then it will not be a 4-digit number, it will be a 3-digit number only. 0, 1, 2, 3. Can we count 0, 1, 2, 3 as a 4-digit number? No. 0, 1, 2, 3 means it is 123. 0, 1, 2, 3 means it is 123. No, someone said that it is 0. No. It is not 0 into 1 into this no. I said this number 0, 1, 2, 3. So the first place, it is not that 0 into. Here we fill the number of chance or the number of possibilities. How many possibilities are here? That is what we write for multiplication. Again, so we cannot start with 0. We cannot start with 0 because starting with 0 it won't be a 4-digit. That means there is restriction for the first place. So for the first place, how many digits can be used? Only in all, how many digits are available? We have 10 digits available. But from this 10 digits, we cannot use all 10 digits because 0 we cannot use. So only remaining 9 digits can be used. From that 9 digits, we need to fill only one place, first place. So from 9 digits, one place can be filled in 9p1 digits. Out of n things, r things are out of 9 things, we are filling one place. So the first place is filled. The remaining 3 places are there. Now we have to arrange remaining 3 places. Again, in all, how many digits are available now? In all, we had 10 digits, but out of the 10 digits means from 0 to 9, we have 10 digits. Repetition is not possible. Out of 0 to 9, out of this 10 digits, the first place we already filled with a number. The remaining only 9 digits are available. From that 9 digits, we need to arrange these 3 places, which is possible in 9p3 ways. So the total number of numbers will be 9p1 into 9p3. Write it. First place cannot be filled by the digit 0. First place cannot be filled by the digit 0. Therefore, from remaining 9 digits, one can be filled in 9p1 ways. From remaining 9 digits, one can be filled in 9p1 ways. First place cannot be filled by the digit 0. Therefore, from remaining 9 digits, one can be filled in 9p1 ways. Next line. As one digit is used to fill first place. As one digit is used to fill first place. From remaining 9 digits. As one digit is used to fill the first place. From remaining 9 digits, how many places? 3 places can be filled in 9p3 ways. From remaining 9 digits, 3 places can be filled in 9p3 ways. 9p3 ways. Therefore, total number is 9p1 into 9p3. 9p1 means 9 factorial by 8 factorial. 9p3 means 9 factorial by 6 factorial. Because by definition, Khaja, your doubt is we can use 0 in, wait, what is your doubt? We can use 0 in second or third, or yes, we can use 0 in any place, Dr. B, except the first place, we can use 0 in any place. So why 9 digits? Because first place, we already filled the first place. It is without repetition. First place we already filled with a number. In all we have 10 digits. Out of that 10 digits, first place is already as 1 digit is used to fill the first place. For filling first place, already 1 digit is used. Now remaining only 9 digits are available. From that 9 digits, 3 digits can be, 3 places can be filled in 9 digits. That is 9 factorial, this is 9 into 8 factorial, 8 factorial, 9, 8, 6 factorial by 6 factorial cancel. 9 into 9 into 8 into 7. 4, 5, 3, 6. Four, 5, 3, 6. Now the same thing. This is by again examination. You don't have to write everything in detail like this, but write very briefly. First place in 9 ways, remaining place in 93 ways, total number. Or by method of counting, we learned it. Again, we have the same 1, 2, 3, 4 places. Such questions, method of counting is more easy. We fill the place with restriction. Which is the place? Do we have restriction? Yes, we have restriction for the first place. First place, we cannot use all 10 digits because 0 is not possible. So only 9 digits are possible. So first place can be filled in 9 ways. The numbers are without repetition. In all, we have 10 digits. Out of that 10 digits, already 1 digit is used in the first place. Remaining, how many are available? Remaining only 9 digits are available. That 9 digits, one of it, all 9 can be used here. Any one of the 9 numbers can be used here. Again, total of 10 digits are available with us. Total of 10 digits are with us. Out of this 10 digits, we already used the 2 numbers here, 2 places. See, this 9 and 9, it is not that digit, it is a number of possible ways. It is a number of possible ways that particular place can be filled. This 9 stands for, this means there are 9 possibilities to fill this place. Which are those 9 possibilities? That can be digit 1, using digit 1, 2, or it can be a number starting with 1 means it can be 1000, 2000, 3000, 4000, etc. up to 9000. Is it? Again, this also 9 means the second place also can be filled using 9 different ways, or 9 digits are available. Again, so out of total 10 digits, we already used 2 digits. Remaining 8 digits available here. Remaining 7 digits. Same thing. 9, 9, 8, 7. So directly we can write in that way also, no problem. Now, coming to question number 3. We have one more period, the last period. Coming to question number 3. How many 3-digit even numbers can be made using the digits? See, now we will use method of counting, permutations. See, how many digits are available? 1, 2, 3, 4, 6, 7. 1, 2, 3, 4. These are the available digits. 1, 2, 3, 4, 6, 7. So in all, how many digits are available? 1, 2, 3, 4, 5, 6 digits are available. From the 6 digits, we need to fill a 3-digit number. We need to form a 3-digit number. Now we have to see whether we have restriction for any of the places. Do we have restriction? How many 3-digit even numbers? That means there is a restriction. Even numbers. So to be an even number, restriction for the last place, this place. We cannot fill any of these numbers in the last place. Why? Because we need even number. To get an even number, from these numbers, it should be 2, 4, or only these numbers are possible, is it? So the last place can be filled using only these 3 digits, 2, 4, or 6. If you are using the digit 1, a 3-digit number ending with 1, it is not an even number, is it? A 3-digit number ending with 1 is not an even number. A 3-digit number ending with 3 is not an even number. Or ending with 7 is not an even number. Whereas a 3-digit number ending with 2 is an even number. So it should be, last place should be one of this, 2, 4, or 6. So this last place we can fill only in 3 ways. So out of this 1, 2, 3, 4, 5, 6. In all 6 digits are there. We already used one number here. 1 digit is used here. Remaining, how many digits are available? Only out of 1, 2, 3, 4, 5, 6. 1 digit is already used. Remaining 5 digits, that 5 digits can be used here. Now, second place, we already used 2 digits. Remaining is 4. So, right, that's it. Write in your own words, we did it. Last place can be filled in 3 ways. Last place can be filled in 3 ways. We will continue last period. Last period we have again. So at the end we will continue last period.